Okay, well, let's just go on 7:30 here in the UK. So I'll get started. Try not to keep you too long. Probably about 20 minutes, I think, this morning. So, welcome to the Petrosys Mapping Challenge. I guess the reason for doing this exercise, we actually initially ran this at the EAGE, but the reason for doing this exercise and for doing this webinar is to sort of think, I guess, a sort of higher level, not just trying to push Petrus as a software, but think a sort of higher level about mapping standards in the oil and gas industry in general, which we regularly see as failing. So the reason for doing this exercise is that we continue to see published subsurface maps full of very critical errors. And we're also told by many senior geoscientists at a range of different companies and company sizes that this practice of creating maps by simply pushing some buttons and accepting the first thing that comes out, with no real geological thought or process, is very common, particularly amongst the younger geoscientists that wouldn't have had to do this sort of thing on paper years and years ago. Now, obviously, this is very worrying for the industry as we move forward with new challenges and new opportunities to target. And so one thing that we strongly advocate in Petrus is the concept of mapping standards. So we've helped a few companies implement these standards whereby geoscientists would follow some sort of guidelines or workflows to create the subsurface maps and really think about the maps based on these guidelines rather than just simply pushing some buttons and trying to move on to the cool modelling phase as quickly as they can. So what we've done here is we've deliberately created a poor map full of the typical things that we see, and we're going to bring that map up in Petrosys in a moment, and I'm going to show you where those critical errors are, where those important problems are, and how Petrosys can resolve these. So I'm going to move straight into the demo. So there's really no slides this morning. If I just bring up my Petrosys map. Okay, so this is the map that I sent out by email, and it's also in the handout section of the GoToWebinar. If you want to download it just now and have a look yourself, that's where it is. So, like I said, I've deliberately created some problems. Some of them are very minor and a little bit nitpicky, but some of them are very serious geoscience problems. So what I'm going to do is I'm going to move to a different map, and it's going to show where these 10 problems are. Now what we're doing is we're assuming that we've created this map perhaps to propose a new well location, and we're going to present this map to our manager, and this is the map that they see. Now when we see maps, we don't see all of these 10 errors together, but typically we will see a couple of them. Some of them are minor, some of them are very serious problems. And so what we've done is we've split it into two categories. Now there are 5 cartography problems, and there are 5 geoscience problems, and I'm going to look at the cartography ones very quickly. I'm not going to spend too long on the cartography ones today, but let's just have a look at them quickly. So the first problem you'll see in this map, there's no coordinates, so very basic. All maps should have coordinates, so we need that. Second thing, there's no map elements on this map, so things like scale bars and north arrows, we need to add these to the map to give extra information about what it is we're showing. Number 3, there's some text on the map that's far too small to be seen. So there's some information about this well, but it's far too small to be seen. Number 4, there's no colour bars or legends on this map, so it's very difficult to see what we're actually showing. And number 5, the title of this map is very poor. So there's some basic cartography things about this map. Now these are things that we're aware that any sort of mapping package can do these things. So you know, if you've got a GIS package, you can easily add coordinates, you can add scale bars. We're aware of that. We're not trying to say that something like a GIS package couldn't do that. So what I'm going to do is I'm going to show you how Petrosys can implement these objects very quickly, and I'm going to move on to focus on the geoscience problems, because it's the geoscience problems where Petrosys really comes into its own. That's where Petrosys adds the value to subsurface maps, because that's where all of the tools that GIS packages will not have, that's where Petrosys really adds value. So what I'm going to do is I'm going to quickly just bring up I'm going to quickly just fix these problems, so you can see that we've added in coordinates, we've added in a scale bar with coordinate reference system information. we've increased the size of this text, and we've put some colour bars showing what it is we're showing. So in this case it's subsea depth, the values are in, it's down to this Humanala formation. We've put in some extra information about what the well is showing, and about what this dotted green line is, and we've improved the title. So we're showing that we're showing a top structure map here. So like I said, these are all very easy things to add in Petrosys. In fact, there's no north arrow at the moment, so I'm going to show you how easy it is to add these things. You simply display the object, so in this case I'm displaying a north arrow, choose your style, so an existing style, or you can create custom styles, and you choose a location, so bottom left, OK, and that's it, done. So that was very easy to do all these things. It took about 5 or 10 minutes to do these things. I didn't want to spend all that time this morning doing that. I thought that would be a little bit boring. And also, like I mentioned, this is not really where Petrosys adds unique value, because we're aware that other packages can do these things. It's very important that Petrosys can do these things, but we're aware that other packages can do those as well. Where Petrosys adds its unique value, and where it sort of sits in the industry and why it's used by geoscientists, is all in its geoscience mapping capabilities. And so what I'm going to do is I'm going to toggle off these 5 cartography things, and I'm going to toggle on the geoscience problems. And there's 5 of them here, numbered 6 to 10, and it's these ones that I'm going to focus on and show you exactly what was wrong with this map geologically and where Petrosys can add value. So I'm going to start with number 6. I'll just zoom in here. And number 6, the problem number 6 is that there's faults displayed on the map, but these faults don't have any information about what type of faults they are, so they don't have fault ticks. Now, in GIS packages, because a GIS package just sees faults as a polygon, they're not aware of what a fault is, and so adding these fault ticks is extremely difficult in a GIS package. Similarly, if you're doing your mapping in an interpretation system, the interpretation system might have a map window built into it, but that map window is not an advanced map window like Petrosys. It's a very basic map, and so sometimes in those packages, adding things like fault ticks can be extremely difficult and cumbersome. And we've even seen horrendous things like people trying to draw polygons to show their fault ticks on their faults. So there's some real horrendous workflows out there. Whereas in Petrosys, if you do your mapping in Petrosys, it's as simple as just double clicking on the object, turning on the symbols and clicking OK. Because Petrosys knows what a fault is and knows what type of fault we're dealing with here. So showing that these are normal faults and showing the dip direction is extremely easy in Petrosys. And that was one of the first geoscience problems that was wrong with this map. Now, going to move to number 7 now, and again it's sticking with faults. And that is that some of the fault information is actually incorrect. So we've got some ticks on the inside of the faults which we don't want here. We want to be consistent with the other faults, and also some of these faults are very blocky. Now, seeing these blocky faults is something that's very common when people generate the fault polygons within an interpretation system. Now, if you imagine a fault in 3D, this shouldn't really happen. It's not common for a fault to look like this in the subsurface. Yet we see it on maps time and time again. So if I zoom in here, for example, and I measure the heave on this fault here, now I don't know if you can see down at the bottom of my screen here, but it says that this fault heave is about 235 metres. So just down this little bit here. So 235 metres of heave. And it's unrealistic to think that a fault would have 235 metres here, but if you move slightly over here, suddenly it's got no heave at all and it just dies out. A fault should always die out to a point like this fault down here. And we see this sort of thing on maps from interpretation systems regularly. Now, interpretation systems, it's very difficult to overcome this, but in Petrosys it's very easy because we have an advanced mapping graphical tool called the spatial editor. Now, using this tool, you can do things like look at the vertices of the fault. So I can come in here and I can maybe drag the vertex over here to make this to a point, or I could edit in some other ways, which I'll show you in a moment. Now, the important thing to remember when you're doing these edits is always to look at your interpretation data. And because Petrosys connects to all of your big interpretation systems like Betrayal and Decision Space and Kingdom and Paradigm and Dug Insight and others, because we can connect all these, you can easily display your interpretation data. Now in this case, the interpretation data is 2D seismic, and you can see that in this area we actually don't have any controlling seismic data. So it's a perfectly legitimate thing at this exploration phase to come in and modify these fault polygons. But when you're doing this modification, you don't want to do it just for the sake of doing it. You want to make sure you're doing it in conjunction with your interpretation data. And unlike a GIS package, Petrosys has the ability to display that interpretation data on the map, so making it much easier for the geoscientists to see where they have controlling data and where they have some freedom to move things around. So let me just turn off the grid just now so we can see this a little bit easier. And what I'm going to do is I'm just going to move, just going to create some points like this. So coming up to some sort of point here. And you can also come in and put on some smoothing. So this tool, once you get used to it, it's extremely easy to use. Just highlight a few of these, put a bit of smoother on. And it allows you to create these much more realistic faults. Now, as I mentioned earlier, there's also some faults that have the ticks on the inside, so I can just easily click on those and invert those, and I can also swap the fault sides if I need to. But in this case, this is the down thrown side. That's the correct side. Now, the value proposition I'm trying to show here in Petrosys is that the Petrosys increases your credibility as a geoscientist really by removing these unrealistic features. So if you imagine if you're trying to present this map to your manager or your or a partner or a government body, you're trying to show them that you are aware of all the geological you're fully aware, you fully understand the geology of this this scenario here. Now, if some of your faults look completely geologically unrealistic, that sort of hinders your credibility as a geoscientist. So by doing these little tweaks, by being able to make these changes on the map, suddenly you become a much sort of higher regarded geoscientist, and that makes it much easier for you to present your geological ideas to your peers. So now that I've made those changes here, what I'm going to do is I'll just toggle off. Let me move this down so I've got more room. I'm just going to toggle off the seismic, and I'm going to move to number 8 on the map. And if I zoom in here, and this is one of the things where we've started to get into real critical problems with this map. And number 8 is that we have some gridding artifacts around the faults. And this is very common because imaging around faults with seismic, particularly 2D seismic, is very tricky. And so you can end up with these artifacts. And a good geoscientist should be able to come in and notice these things straight away. But yet we do see maps with these sort of things all the time where people haven't actually bothered to look at them and recognise that these are not actual geological features, they are gridding artifacts from the software. In fact, if I turn on interpretation again, you can see these little bumps that sort of run along this fault here actually line up perfectly with a couple of seismic lines coming through here. And it's just because of poor interpretation on these seismic lines. Now at this stage we could go back to the seismic and reinterpret it, and because Petrosys connects directly to that interpretation data, we would simply rerun the workflow and that would update without those artifacts. The problem is that often, because of poor imaging around faults, then it doesn't really matter how much you go back and reinterpret it, you'll never get rid of these artifacts. Now Petrosys has a tool to improve this on the map, and again you need to use it with a bit of thought and a bit of care, but there is a tool to edit this grid, and as long as you're using it in a geological way, it's a very powerful tool to have at your disposal. So what you can do is you can drag grids into the spatial editor, and you can edit these from within here. So if I expand this grid layer here, I just need to make a couple of changes. I just need to automatically regenerate contours. I'm not going to grid inside the faults in this this scenario. What you can do is there's various tools in here, but one example I'll show you is there's a smoothing button to smooth the grids. So I can come in, I can adjust the edit circle, make it a little bit smaller, and you can click around these artifacts here to smooth them. And hopefully you can see on the screen here that that's smoothing the contours around this this faulted area here. So you can do things like that. You can also edit the data more manually if you you want more control. So the example I'll show here is I'll switch to the contour mode. And we have, in this case here with the sparse data, it's created a couple of isolated structures. You could easily come in and create a single structure if you wanted. So you can, let's say, remove some contours in this area here, and then I can come in and I can redigitize the contours like this, for example. Now, again, as long as you're using it in conjunction with your interpretation data, then this is a very powerful tool to use. a bit smoother on that contour there. When you've done those changes to the contours, you can regrid the data with the contours. Now you can regrid the entire area, or a powerful advanced tool that Petrosys has is the ability to regrid a localized area only. So in this case here, I can adjust the buffer if I want, but I'm gridding only the area that I've edited, which means I'm not affecting the data far beyond this area. It's only that edited area that's affected using this localized regridding technique. And that's a very powerful technique that you won't find in other applications. So again, a good unique reason to use Petrosys for your edits. Now, once you've made those changes, I'm going to move on to number 9 on the list. And number 9 on the list, and if you spotted this, well done. It's something that if you're used to looking at maps and if you're thinking about your maps, you can spot a mile off. But we see it time and time again, and we see people not actually caring about this, and that is that the contours in this grid actually run straight through the fault. So if you look at this 2,000 meter contour, for example, it enters the fault here and leaves the fault here. Now we've shown on this map that this is a normal fault, so it should be dipping around 60 degrees, very steep dip on this fault. However, what our map is showing is that if we enter the fault here, we're at 2,000 meters. If we exit the fault here, we're also at 2,000 meters. So the contours are actually showing that this fault is actually flat, which is completely the opposite thing that we're trying to show on this map with these normal faults. So it's completely incorrect. And the reason for this is that in interpretation systems, quite often you can't include the fault within the actual mapped surface. You have to spend days or weeks generating a full model before you can include faults and surfaces. And in Petrosys, that's something that we just find quite bizarre. It's something that's so easy for Petrosys users to do, but yet if people try to map in interpretation systems, you're not able to actually include your faults in your grid. And so what people do, and what we've actually done here deliberately, is we've generated a surface without faults, like this, and then we've simply overlain the fault polygons onto that surface to make it look like there are faults in here, but in actual fact they're not part of the grid, and so you get these horrendous things. Now, first of all, it's important to do this to make your map look realistic to the person you're presenting it to, but secondly, it has huge implications for volumetrics for this structure here, which people just seem to forget about when they're doing their mapping. So that's why we try to encourage people to use Petrosys and include their faults in their grid. Now, it's extremely easy to do in Petrosys. If you want to include your faults in your grid, you simply toggle on Use Fault Data, like that. And you point to your faults wherever they are, if they're in Betrayal or Kingdom or wherever they are, you point to your faults, and whether it's fault polygons or fault sticks, we can use both of those in Petrosys. Click OK, refresh the map, and it's as simple as that. You can see that these contours will now will update properly based on that fault information. So now what the map is showing is that we enter the fault at 2,000 meters, and if I track along here, down the bottom of the screen, it shows that's about 1973. So about 25, 27 meters of throw on this fault, so perfectly realistic for a normal fault. So very quickly and very easily, we've improved the map, and we've improved the volumes that we're going to calculate for this map in Petrosys. Now, number 10 on the list, the very final one, and again we see it a lot when you're working with 2D data, sometimes with 3D as well, and that is there's a linear artifact running through this area here. And again, it's something we see on maps that people just forget about and move on, and they would use this surface for their models without actually fixing these things at the initial stages. So you can see all these little bubbles here, they sort of line up in this linear orientation, and if I toggle on my seismic, you'll see that there's a seismic line running straight through these faults. And so what it means is there's poor interpretation on this seismic line. Now at this stage, obviously, you could go back to that seismic line and reinterpret. However, if you don't have that ability, or if that's not something you want to do, there are options in Petrosys to improve that structure. I'm going to show you a couple of them here. There's actually quite a few methods, but I'll show you two of them. The first is to turn on this advanced editing tool when you're creating your grid. So if I just run this grid again, this advanced editing tool will pop up, and it's called the sample data editor. And what you can do is, if I just increase the size of these squares, is you can easily come in and see that in this case here there's some misties. So these points running through here don't tie up with the points underneath, and that's where you're getting this artifact, these bubbles from. Now you can, if you want, you can draw a polygon around these points, and you can say to Petrosys, don't include these in the grid creation, and those will be removed. Alternatively, what I would probably do in this case, so I'll just exit out of this, what I would probably do in this case, because I have a reasonable amount of data, is I would go into the input and I would create a selection file. So whether I'm using data from Petrel or from Kingdom or wherever, I can create a selection file in Petrosys that takes out that line, uses a line selection file. And if I now run this task again and zoom in, you'll see that that line coming across here is no longer included. So if I click OK to finish this grid and then click on refresh, you'll see that those artifacts, those linear artifacts, are now completely gone. So very easy to remove those. So I guess again, just showing you that just a little bit of thought combined with all of the tools that Petrosys gives you allows you to create this much higher quality map than you would otherwise have. So let me that's the 10 points I wanted to get through. Let me jump back to PowerPoint. I want to just finish with one slide, which is a quote from the chief geologist and chief geophysicist of a mid-sized independent company, just talking about what they see and what they feel about subsurface maps. Now, they say that maps are one of the most important tools used to help describe the subsurface. They serve a number of purposes: to record and store information, to support the analysis of a range of subsurface data, and are the fundamental work product that the geoscientists across the breadth of the business use to present and communicate information and understanding. And I think that's a very important quote that people creating maps really need to be aware of. Maps are not just something that's a little bit of a pain and you have to create just as part of your portfolio that you're creating. Maps are absolutely critical to convey your information and understanding. And if you're not creating your maps properly with a good thought process, then you're not presenting what you know about a structure properly, and you're not presenting that information and understanding to others. So it's very critical that we think more about maps and that we employ all of the tools at our disposal to improve them. So thanks very much for listening. What I'll do in a moment is I'll unmute everyone. If people have questions, please just you can just talk away, or if you want to enter text into the chat log, please do that and I'll answer questions just now. There's also some details here of how to contact us. And one final thing I'll also do is I'm going to add an answer sheet to the handout. So if you do want to have a look through the answer sheet, then please do. Or if you want to pass these on to others. So what I'll do is I'll just drag that PDF into the handouts panel of your GoToWebinar. So if you want to download that, that is it now available. Okay, let me just unmute everyone and see if we have any questions. Okay, if you have any questions, just fire away. Okay, well, it seems like we don't have any questions this morning, so what we'll do in that case is I'll end this webinar. This video will be available on our website later on in the week, so if you want to show this to other people, then please go and look at it there. And if you do have any questions, please get in touch with us at the usual support email addresses or through my own personal email address, which is on the screen just now. So thanks very much for listening, and I hope you all have a good day.